G'day guys, Mr. Bennett here. Today we're going to be going through just an example of how to model some data and find the equation of that using the sine curve. So let's do that now. So obviously the first thing, if you get a table of values, you need to put that into your calculator. So obviously January, you can't write in January, February, March. So you're going to say January is 1, February is 2, March is 3. So that's what you're going to put in for those values there. So simply go into your calculator, and I do have some printed instructions for you for that. I'll just quit out of there so you can't see anything. So the thing that you need to do is you need to go to your stat button, press that, and you go to number 1, which is edit. And then all you need to do is you type in your values. So 1, 2, 3 in list number 1. And then you put your values 28, 27 and so on in there, just typing those and pressing enter after each one, and you've got your data in there. So that's the first thing. The next thing you need to do is you need to go to your calculator and just clear anything that's actually in your y equals. Alright, and then we need to go to our stat plot, and we need to turn our stat plot on. So we go enter, and we go on, enter. We're going to do a scatter graph, and then we're going to use list number 1 and list number 2. Okay, they're the two things. And then what you will need to do, if you go graph there, you won't see your data most of the time. So then what we need to do is go zoom, and the zoom stat fit, which is zoom 9. Okay, and then you can see the curve that you actually got here. So that's my data that I've actually got. The other thing that I can do with that now, if I go to stat and go across to calc, if you're going on your up arrow, you can actually do a sine regression fit. Alright, so I'm going to do list number 1, list number 2, and then we're going to put our period, which is 12. Okay, it's 12 months, and then our store. Now, if we're going to store that, we can put that into y equals. So you press vars, go across to y vars, go to number 1. I'm going to store that in number 1. Okay, so what will happen is we'll calculate the value and then store that equation into the y coordinate. And when I go graph there, you can see it actually fits perfectly with my curve here. Now, for that to do that properly, you need to make sure your calculator is in radians. Alright, so if you do that and graph, you get a nice perfect fit, and then in y there is actual the curve. Alright, so if you scroll across, you can see the function that's being produced out of there. Alright, so obviously it's got a lot of decimal places there, but we're not going to go to that extent, are we? Alright, so again, just the process is you go stat, across to calc. We scroll upwards to go to our number C, which is sine regression. Iterations, we'll keep that at 3. We're using our list. Now, you don't always have to use list number 1 or list number 2, but that's where it is. We know this is a 12-monthly period. Okay, and we're going to store that in Y1. So we go vars, across to Y vars, number 1, Y equals, and then go calculate. It will find the actual thing for me. That's my function, tells me my amplitude is 6.33. My B value is 0.518 or 19, probably going to 3 decimal places. And then my C value is 0.9942, and then my D value is 21 point. Okay, so that's my equation. Now what I want to do is also be able to manually find that graph given some information. Alright, so I've got my calculator that will do that. Now you'll use this process also in your equation. Now if I had my D value, which is 21, if I do that, put that in that 21 or whatever it worked out to be, and graph, you can see that roughly goes through the middle. That will give me an idea about what my C value is, alright, for my equation. So let's go back to that. Alright, so in the textbook it's got these values here, but I was going to go through that bit. So the maximum value you have is 28, the minimum value you have is 15. So I need to, for my equation, I need to recognise that my particular equation here is simply the value there, y equals a sine b of x take c plus d. So I need to find all those values. That's what I need to be able to do. I know my min value is equal to, min is equal to 15. My max value is equal to 28. Alright, so easy to find my A value and my D value. So my A value, amplitude, is going to be equal to my max, take my min, all over 2. So that's going to be 28, take 15, all over 2. So that's 13, divided by 2 is going to be 6.5. That's my D value. My A value, so my D value is going to be my max plus my min. This is my median line divided by 2. So that's going to be 28 plus 15 divided by 2. So that's going to be 30, 43 divided by 2 is going to be 21.5. So that's my D value. My period over here is, we know this is the month, is a yearly cycle. So my B value is equal to 2 pi divided by the period, isn't it? Okay, so that's going to be 2 pi divided by 12. So that's going to be work out to be pi on 6. So that's what my B value works out to be. There, the only value that I have possible trouble finding is my C value. So what I'm going to do over here is I'm going to go back to my calculator. I'm going to change that because that wasn't 21, it was 21.5. And enter. And then what I'm going to do is I'm going to graph that. Because I've got my line of best fit and I've also got my line 21.5, that's going to allow me to find the intersect point. So this is the intersect point here that I actually want to find, where it starts going up there. So I'm going to go to my second function calc. I'm going to go number 5 with an intersect. I want to get close to the point which I want to find, so I have to go below that minimum. So I'm over that side there, and so now I can go simply enter, 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 and it will find that coordinate there. That tells me that the x coordinate for that intersect is in fact 10.2. So that is going to be my C value. Okay, is that line, because it's going upwards, so therefore this is being moved this way, right, 10.2. So therefore, going back to my equation, my C value from my curve is in fact 10.2, and that's what I need to do. I need to find my median line, the line where it oscillates about, and then I need to find the point of intersection. So this here is the equation of my line over here. If I need to write that now, I could say my line y equals my A value, which is 6.5, sine of my B value, which is pi on 6, x take 10.2, and then it's plus 21.5. Now, the calculator, how you have to put this in the calculator will be slightly different to that. Actually, I'll do it below. That's going to be 6.5. I need to combine this pi on 6, so that's going to become pi x on 6. Take 10.2 pi on 6 plus 21.5. So that's what I need to put into my calculator. So let's come down over here and we'll do that as a second graph. So it's going to be 6.5 sine, and that's going to be, what was it? Pi x divided by 6, take 10.2 times by pi, divide by 6, bracket and then we have to add 21.6. Right, now I'm going to turn the top graph off so you can see it doesn't actually, so I turn it off by going in and going enter. That won't actually graph that first line now. So if I graph that, that's my line there, and you can see this one here is my equation that models that curve there quite well. Alright, get the idea? So that's really the process that you have to go through. That's really an essential part of this whole course, is actually to match the sine curve and the cosine curves to equations. In your textbook, obviously, they had that example. Alright, so I've actually put this into this document for you. So simply, I would write down how to find my B value, write down how to find your A value, write down how to find your D value, and then the C value is probably the hardest one. And again, what I was doing there, when you think about what I was doing, is I was graphing my calculator and I was using that point there where it goes up. So I have to find that coordinate there, and that is going to be my point every time. So once you get the idea, that's really useful. The sort of questions we would do from here now, because this is showing you the temperature, I might ask you a question which is something like this. Obviously, when the temperature is going to be over 25 degrees, okay, so if I change this, and I can change this value here to be 25 degrees, clear that. Right, so what parts of the year is the temperature going to be above 25 degrees? Right, because I've got my model, I can actually find those things. Okay, so technically, what I can do now is I can use my calc, and this is what you've got a calculator for. Number 5. Okay, if I go that way, I'll find this point. I go enter, enter. Okay, so 3.15 months into the year, the temperature for the first 3.5 months, the temperature is in fact over 25 degrees. And then if I want to find the second point, then what I would do, second function calc, number 5, scroll across, or you can put in the value of, say, 10. Oh no, you can't do that. Thought you could. So number 5, scroll across. So I just need to get the other side of that minimum point. Enter, enter. And then that worked out to be 11.25 months into the year. The temperature goes over 25. This is obviously the average maximum temperature of this place. So then you would know what part of the year that the temperature will be over 25 degrees, and that might be an idea of how you open the town pool. You know, you open the town pool when the average temperature is over 25 degrees. So for these months between here and here, you're not going to be opening the town pool, because that's, you know, doesn't make sense. So if I was actually doing this, I would be doing a little sketch of that. You know, that's what I do a little sketch of that and actually label those points on your graph. Alright, so your curve goes something like that, 25 degrees. Okay, that worked out to be 3.15. That worked out to be 11.25. Got the idea? Alright, so hopefully this makes sense, and hopefully you can do this.